Hi, I'm Jerry Buxton, Vice President of Engineering, and I'm sorry I'm not there. I really am. For 11 to 12 years of doing this with AMSAT and being at Hamvention, I thought, well, I'm going to miss this one. I guess that's okay, but it's not as easy as it sounds, is it? So I guess I could sum up my day yesterday, which was kind of messed with a little bit by Mother Nature, and spent quite a bit of time at DFW Airport. But I put out a tweet that said, I left for Hamvention this morning and I got home in time for supper. That sums it up. So there's a lot to talk about engineering, and I'm sure that's what you want to hear. Let's go to it. The golf program. I thought we could go ahead and start with some of the main events that are going on right now. The golf program, the biggest one, if you will, Greater Orbit, Larger Footprint, is the acronym. And that is simply because G, the seventh letter of the alphabet, is the next letter after X, like Fox, and E like Echo, AO51. So golf is not something you typically encounter with satellites. I figured I'd come up with a wise acronym. Whether it is or not, I don't know, but it's what we're talking about. What we plan to do is the program itself is a series of satellites for flight testing and qualification. We're going to be looking at missions that test various systems and devices that we're going to need as we move to HEO. Each one of them carries an amateur radio payload, so every one of them will leave that behind once their main mission, if you will, of testing is done. I'm looking to increase orbit heights, but that's been a little bit difficult due to the orbital debris rules. I'll touch on some more about that later, but that's where the greater orbit, larger footprint derived from. And something that we have to harness before we get out of LEO is the ability to make accurate maneuvers and do collision avoidance, because there's a lot of traffic up there now. Hopefully, we will be able to get beyond that so that ultimately our perigee is still above 2,000 kilometers, which gives us, or exempts us, I guess I should say, from that specific orbital debris rules. But the fact that we can maneuver also gives us the opportunity, besides deorbiting when we need to, but to raise our orbit or lower our orbit and alter it to a degree so that we can have a perhaps longer mission. And speaking of longer missions, survivability is a big thing, especially as we get into the Van Allen belts and such, and away from LEO, where there's a lot more radiation bombarding you. So the radiation tolerance idea of COTS parts, or in some cases, I believe probably when we do a HEO or a GTO, something like that, we're going to be wanting to use some rad hard parts so that we get the best life out of it. So what we're looking at is the lowest cost, the best bang for the buck. It's a trade balance so that we can keep as many satellites in space as we can successfully and return to HEO. In order to do this, I'm going to say that we're going to master some satellite operations necessary for higher orbit. This doesn't include, or isn't just engineering, but it includes operations who will be controlling the satellites. They have to have a good understanding of what they'll do, and we have to have good instructions for them to be able to control them. So some of the main items for going higher are power generation. We're going to need more gain on your PA for your radios, for example, to help overcome the link budget. And SDRs themselves can get busy and use up quite a bit of power. There are other systems that we're going to want to have to keep running with more experiments and such as we get back into that. So power is a premium thing to be wanting to get, and I'm talking about power generation from the sun. Also, then we have attitude, determination, and control, ADCS. This is something that's vital to being able to control the satellite to point, for example, for best sun, or to maneuver. We have to be pointed very precisely if we're going to fire any thrusters. And also, we'll say point microwave antennas back down toward Earth so that we have, trade-offs. We can assume different attitudes for different operations. The radiation tolerance and hardening I mentioned before, that's something that's going to be essential to survival. In the older days of the satellites, there weren't so many chips, ICs on them, if you will. And so the analog parts, the wire around, or the resistors, carbon resistors, and what have you, much hardier in the radiation environment. We're going to be moving to microwaves. 10 gigahertz band is the ultimate downlink band. There's a lot of bandwidth up there in 10 gigahertz and 5 gigahertz, which is the C band uplink. We're also adding 2.4 gigahertz S band uplink because that shares with Europe what they have over there with QO100. And then thrust and propulsion will be probably the icing on the cake, if you will. Once we've mastered all of this, again, mastered it so that we can be responsible spacefarers, then we head to HEO. The current Golf projects underway. We have Golf T. Golf T stands for Technology Exploration Environment. Sorry about that. And taking the numbers from the last slide, we've got deployable solar panels that we're developing in-house that is in addressing the power, more power situation, if you will. We have secured CubeSpace ADCS that we will use for that system. We were working with one prior that was a startup that would have given us an opportunity to fly cheaper and also be part of the development, but that did not come to fruition. CubeSpace, after a long search, we actually looked at, or Hilly Page did most of the work, a lot of different ADCS, and we found what was suitable for our missions for Golf T, Golf 1, and possibly beyond. We've got the RT-IHU, radiation tolerant IHU, that was developed as an ASCENT project, and it is using COTS parts intended to reduce the number of upsets or that cause the IHU to either latch up or have to reboot and such like that. And we're going to compare that then with the legacy IHU, as we call it, on the LTM, linear transponder module, to see if, especially South Atlantic anomaly, probably, if we're doing any better as far as resets on each of those IHU systems. And then for the 10 gigahertz X band, we're going to do an experimental microwave downlink high-speed data, which is something we'll be looking for. It's tricky at LEO, but as we go higher to HEO and such, there's a lot of data that you want to download, not to mention experiments and what have you. And it also gives us an opportunity to possibly use it as a transponder, where we would pick off the UHF downlink of the VU transponder and send it down on 10 gigahertz as kind of an entryway for people to give a try to the microwave bands. We're looking at a 500 to 550 LEO orbit. This is a CSLI Alana, as a matter of fact, orbit, or launch, I should say. And it's testing and qualifying the new technologies, but also Vanderbilt ISDI radiation experiment, as we have flown before that, I think can help provide a comparison of what the environment was like in the RT-IHU versus IHU, LIHU comparison. We should have a good radio footprint up at 550, and it's orbital debris regulations friendly because it will decay rather rapidly, actually, at least in the current sunspot cycle. So when we get going, we'll see when that is. That can make a difference. And I got too hasty. So we've got Golf 1 then next. Golf 1 is using the same goals, number 1, 2, 3, and 4 from Golf T that hopefully are developed quite well. And in the meantime, though, if there are things that we find in the construction, in the on-orbit phases, then hopefully we'll have time to make adjustments to that, to improve on them. That's always, the way you want to go with a series of satellites that are similar. And a typical mission, this will be a typical mission versus the technology mission that Golf T is, where we carry STEM experiments, so it's educational based. We have a high school in San Diego area who has been wanting to fly a camera for Earth weather views, and then we'll fly the Vanderbilt ISDI student radiation experiment again. They have a lot of students that like to put those together and write papers. We'll expand the SDR microwave experimentation to open up 5 and dime, and that's the 5 gigahertz uplink, 10 gigahertz downlink. Of course, it is at LEO, tricky at best. Nonetheless, it will be there for experimentation starting with Golf 1. And again, the SX band, 2.4 gigahertz up, 10 gigahertz down, a la QO100. And we have an L-band uplink capability. Not certain what that will be used for, perhaps commands, but it's not a worldwide band. So depending on resources, I think we'll probably concentrate on the other microwave bands primarily. And again, we'll have a standard VU operation transponder. However, it'll be the SDR now and not the LTM. So that gives the opportunity to make the transponder a variety of things, FM repeater or, linear transponder. And Ray can tell you a lot more about that. He's working the SDR. And he's had actually presented in the past some really good ideas for what you can do with a VHF, UHF, SDR, for example. And then we look at the charts here, if you will. And we have Golf T with the readiness date, of December 1st, 2025. The readiness date indicates to NASA that's the date that we're ready to hand it over for integration. And integration, of course, is the activity of putting it into the dispenser that then goes to the rocket. NASA holds off till basically CDR, which would be March of 2025, and then looking at that readiness date in order to judge and find a good launch for it. The launch date or the integration is typically 45 days prior to launch. Therefore, we would not see a launch until early 2026. But that could happen that fast. They've been pretty good at lining up some launches very quickly for it. And then we have Golf 1, readiness date a year later, December 7th, 2026. Again, we want to look at everything we can learn from Golf T to put it in Golf 1 and make it better. So then beyond that, with the Golf program, we have from Golf 2 and on, the push for opportunities, and I say it's a good push, but opportunities for higher than LEO are going to require specialized systems. We know that. So this is going to be where Golf 2 and beyond start testing more and more of these systems. The orbit devices, they're just coming to commercial availability in CubeSats, which is very good. They were not available up until just recently. We found at CDW, the CubeSat Developers Workshop, that there are quite a few companies that have some items coming out that are helpful to us. So what we can do is we can look at that. We can look at thrusters and propulsion, and we have a team working on that in the ASCENT group. And these things can be mastered. Again, I like to use that word, but developed and mastered in LEO. And then beyond LEO, we look at the idea that we right now have a mission lifetime of about 5 years and 5 years to return after end of mission according to the current orbital debris rules. So that gives us about a 10-year mission lifetime, 10-year flight lifetime, I should say. So we'll be very careful about what we fly in order to make it a successful mission as we go for those higher and more expensive orbits. But what we do in LEO it could, as we become expert in that, master it, we don't necessarily have to have those higher orbits that I originally had envisioned to put us in more radiation and such. Now that would be helpful, but you can test some of that on the ground. Nonetheless, that all that testing can be done in LEO. And then that's a good segue to our Fox Plus. Fox Plus is the next generation of the popular Fox 1 satellites. And Fox 1 FM repeater satellites, with the exception of Fox 1E, 1U CubeSats, were very popular. And we stopped the Fox program for two reasons. One, a lot of the parts went defunct, and it would take a redesign, literally redesign of the thing in order to continue building them. And number two, the engineers are happy or thirsty for something else to keep happy. And that would include me. So that's why we moved on to golf with that. But Fox Plus comes along with a shorter period from design to launch, as were the Fox 1s. And that can help keep this steady flow of satellites going to LEO. So there's always something or two or three up there for people to use, including EasySat designs in some cases where those are popular for beginners, very popular. And I think they brought in quite a few new members and satellites enthusiasts to the amateur satellite world. But they can be all sorts of different types of design. Some of that is looking at new technology, because we can take things that come out of Ascent, for example, that may be destined for Golf 1 even, ultimately because of what their specialty is. But we can get on orbit testing with Fox Plus in order to find out what we have to deal with and what might need to be tweaked before we put it up on something higher up. And that facilitates concurrent development of both of the satellites, which is where we had the big gap with the Foxes. Everybody was working on golf, but now we have more people coming in. So it can also take more than 1U form. Fox Plus is looking at being able to be 1U, 2U, 3U, depending on what the mission is. And I think that primarily the VHF, UHF band, not microwaves, excuse me, will be what is used simply because of its posture in LEO. Mike Moore, K4MVM, is the systems engineer. He's leading the Fox Plus. Assumed that from Jonathan Brandenburg when Jonathan had to step back. There's new engineers coming in that are volunteering for mechanical and software. We're looking at launch possibilities, including purchase launches to, say, for NanoRacks, for example. NanoRacks launches primarily from ISS type of stuff. But NASA CSLI is also open as an option for a free launch. Although it might take a little longer to get up there, it depends. And that includes some ISS launches off NanoRacks and such. They have a bandwagon program that goes up to about 400 kilometers, and then transponder, transporter is very popular to get up above 400 up to 550-ish. So we have lots of work to do, and we need human resources to beat Golf T. So we got a race there. Fox Plus A progressing toward, I would say, a fourth quarter 2025 ready date, much like Golf T. We're using ISOSpace hardware and it's on hand or ordered en route, including the antennas, their EPS, and their solar panels. We'll fly the LTM-1 as the avionics. That's the legacy IHU, which has space heritage, as well as the improved command receiver and the transponder with the 30 kilohertz bandwidth. This is because it's the first one up. We're putting in reliable parts, buying reliable parts in order to make it most successful. So we'll skip over to Ascent now. Advanced satellite communications and exploration of new technology are skunkworks, as it was dubbed by Tom Clark, SK. This Ascent brings in projects that are just design ideas from engineers interested in working on them, a particular system or design, as long as they are in keeping with the idea that we're improving satellite communications with new technology and such. In other words, we can fly them, then all ideas are welcome. And the work in Ascent is done independent of what we're flying, but I know what missions we might be able to fly, much as we did with Golf, where Ascent had RTIHU, for example, and I knew that there would be a mission coming up for that, and so we were able to grandfather it, I guess you'd say, or otherwise incorporate it into it. They also have current projects you may have heard of, or if you haven't, stop by the AMSAT engineering table. PACSAT is a 4 channels up, 1 channel down packet BBS that Bill Reed and a group are building. We have some interested partners, CubeSat partners, that will probably wind up flying that first. Otherwise, it will definitely fly on a Fox Plus B, probably most likely. We have a group working on what we call SDRB, which is an improvement to the EDIS E310 SDR, just basically layout, because that board is big, and that's what causes us to have a funky avionics bus inside of Golf T, and that makes it really interesting to try to fit stuff in there and keep it on their own particular bus. We have a group working on thrust/propulsion that just started out. We had a meeting last week, and we have some good volunteers, solid volunteers. This stuff can help us definitely in the future as we look for that to be part of how we go upward to HEO. And ground station. This is a new endeavor undertaken by a volunteer, Jonathan Brandenburg, coming back, if you will, to work on the 5 and dime ground station. This is something that really started in 2015 and never, can't say made it off the ground, because that's where it's supposed to be. but it was basically left in limbo in a sense because we didn't really have anything to use it on yet. Phase 4B didn't go. CQC, the Cube Quest Challenge, didn't go. So we just knew that we were going to have it fly on golf eventually. And so here he is working on that. So we've got a lot of great stuff going to carry us forward here. And of course, none of it would be possible without the fantastic work of all of our engineering volunteers. I'm just the face and the voice, if you will, although I do have one function that I'm quite proud of, and that is to find launches and get us on the launch and be the one person that you will be able to come to and say, when are we going to launch? And I will tell you, I can't tell you that. Be sure to stop by and see everybody at the booth and also the slideshow. And I believe that I know I ran over by about a minute here, but I believe that they can take some questions possibly there on site. And I thought because I'm not there, I really do, and I've been thinking about this a while, I've wanted to engage with everybody. So perhaps a Twitch or YouTube live chat so that I can just sit there and answer questions, basically. And if you're interested in that, send a tweet or something. I would say send me an email, but my emails get so buried. n0jy@amsat.org. That one works. Otherwise, raise your hand or such. I think that there's enough people out there interested. It's just coordinating a time. And with that, 2 minutes over, but hey, what can I say? I'm going to go ahead and say, we'll turn it over. Sorry about this. There I am. We'll turn it over to the engineers there to answer some questions for you. And I really thank you for your attendance and support of AMSAT. And if you're not a member, I urge you to join.